Now let's give this system a try, and you notice, as you're writing these equations yourself, you see the first one. 2x minus y minus 3z is 1. And then you notice the second one, this is completely independent from the first one, right? This is, like, here is double, this is not double, right? So these are two independent equations. But then you start to write the third, and then you notice this. Look at that 4. That's double, and then here, double, and then here, double, and then here, double. So the first equation and the third equation are not really independent. The third equation is just double the first one. So it looks like we've got 3 equations, but in reality, we really have only 2. And what you see is double, 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 all the way through. So it's the same multiple all the way through, and that means that at least 2 of these planes are coincident, which means no unique solution. But now suppose you didn't see that. So we're just go ahead with our computation and see what happens. So what we're going to do here is we're going to eliminate z, just because I'm used to eliminating z first and getting x and y, but you could choose to eliminate x or y with the same process. But I'm going to eliminate z using, okay, you know what, first I'll number these. 1, 2, 3. So first I'm going to use 1 and 2, and then 1 and 3. So using equations 1 and 2 to eliminate z, and we're going to be getting x and y. So let's use 1 and 2. So focus in on those z's. They're already opposite signs, which is nice. Make them opposite numbers. So this is 3 and 4. The smallest number they divide into, both of them, is 12. So let's make them 12s. I'll multiply the top one by 4, the bottom one by 3. So what we're looking at is this. The plan is like 4 times equation 1 plus 3 times equation 2. And here's what it looks like. All right, 4 times equation 1. So send that 4, 1, 2, 3, 4, through all 4 of those terms. We will get 8x minus 4y minus 12z equals 4. Let me just check that. Multiplying by 4, so 8, negative 4, negative 12, and 4. I've got them. Now, 3 times equation 2. So run a 3 through each one of those 4 terms, and I think we will be getting 3x plus 6y plus 12z equals 9, and add those 2 equations together. How about 11x plus 2y, and the z's are gone, which was the plan, equals 13. Okay, let me circle this one. So there's an equation that we got here, and I'm going to name that equation 4. Now, all right, so that was 1 and 2. Now using 1 and 3 to eliminate z, getting us, again, x and y. So, with 1 and 3, focus in on these coefficients. I got a 3 and a 6. All right, they're the same sign, so I'm going to have to use a negative multiplier. The smallest number they both divide into is 6. So I just need to multiply a top equation by 2, but I need a negative multiplier. So how about negative 2? So here's the plan. Negative 2 times equation 1, and then no change to equation 3, so just add that to equation 3. Now, multiply equation 1 by negative 2. So I'll multiply every one of those 4 terms by negative 2. I'll get negative 4x plus 2y plus 6z equals negative 2. And then no change to equation 3. That's just going to be 4x minus 2y. You can see it already. Minus 6z equals 2. And when you add these 2 together, everything on the left goes out, and on the right it goes out. You're left with 0 equals 0, which is a true statement. And we know that if you eliminate all the variables and are left with a true statement, then visually, geometrically, we've got at least two coincident planes, and we have what we're just going to write as no unique solution. So if we had gotten a false statement, we would say no solution, but we got a true statement, so no unique solution. Infinitely many solutions.